Okay guys, do a little dance because it is the last video notes of the year. Woo! Okay, but these are very, very important ones, so make sure you're not in summer mode yet. Pay attention. This is something you will use so much in geometry, which is why we're doing it at the end of the school year, so it's fresh in your mind when you get to geometry next year. Okay, I have two formulas for you. First is the distance formula. So it's for finding the distance between 2 points, an xy point and another xy point. So if we're looking at a graph and you have a point that is, say, here, and a point maybe that's up here, and you want to find the length of this line between the 2 points. Okay, and say this one looks like it's 3, 4, and this one would be like 1, 1. So you would use these coordinates, 3, 4, and 1, 1. Okay, to find the distance here between those 2 points. So let's find the distance between 2, 4, and 4, negative 3. 2, 4, and 4, negative 3. So I have first x1 is 2, y1 is 4, x2 is 4, y2 is negative 3. So you do x2 minus x1, or you can just do x1 minus x2, it's really the same. But they do x2 minus x1, so 4 minus 2 squared plus, and then, so this is a plus, but in between each of these is a minus. Okay, make sure this formula, you will have to memorize it. It's the radical of the x's subtracted and squared added to the y subtracted and squared. So then y2 is negative 3 minus y1, which is 4. So now we can say, okay, that'll be radical. 4 minus 2 squared will be a 2 squared. Plus negative 3 minus 4 is negative 7 squared. So then you have radical 2 squared, which is 4, plus negative 7 squared, which is 49. So you have radical 54, which you can reduce. You can take out a 4, and that'll be 4 times, ooh, actually you can't take out a 4, I apologize. Never mind. And I don't think you can take out a 16. But I'm going to check that really fast, because I want us to reduce as far as we can possible. Oh, I see what my error was. 4 plus 49 is 53, guys. Like the last video, Miss McMillan is ready for summer. She can do math. Maybe not. We'll see. Which can definitely not be reduced. Oh. This is well, it's struggling here. So this was a 2 squared plus negative 7 squared, which is radical 53, which cannot be reduced, but you can estimate it to be about 7.28. So the distance between those 2 points is 7.28. Let's try another one. Okay, it's radical, subtract your x's. I always do x1 first, it doesn't matter though. Because I think it's silly to start with the second one. So I have an x3 minus negative 5 plus 1 minus 2 squared. So then that'll give you a 3 minus negative 5 and 8 squared. Plus 1 minus 2, negative 1 squared. So you get 64 plus 1, which will be a radical 65, which if it wants you to leave as a radical, you can keep as your answer, or you can reduce it to about 8.06. Okay, go ahead and try number 2 on your own. So now we can apply this to find out if something is a right triangle. So remember, if something is a right triangle from the last video, you have your legs A, B, and C. You know that A squared plus B squared has to be equal to C squared. So I know this seems a little complicated, but you'll have to find your your 3 distances so you can compare. So if we are correct and this is a right triangle, this squared, A here, and then B plus this B squared here, will equal that c squared right there. So let's find our distance 1, which is between 1, 0 and 3, negative 1. So we're going between 1, 0 and 3, negative 1. So we have our x1 minus our x3, or we can do 3 minus 1, also works. In which case we have to do negative 1 minus 0. So that'll give us a radical 2 squared plus negative 1 squared, which is a radical 4 plus 1, which is a radical 5. I'm going to leave it like that because it's actually going to be easier for us when we square them later. So that's a radical 5. Let's do our distance 2 here is between 1, 0 and 4, 6. So now we're using 1, 0 and this 4, 6. So we have 4 minus the 1, or x minus our x, and our y6 minus our y0. So that'll give us a radical 3 squared plus 6 squared, which is a radical 9 plus 36, which is a radical 45. So that's our second distance, our second leg. Now let's do our hypotenuse, which is between 4, 6 and negative 3, negative 1. So this one and this one is what we're using here and here, our second two. So we have radical, I'm going to rewrite them. So we're using 4, 6 and 3, negative 1. So you can go front ways or back ways, 3 minus 4 or 4 minus 3. I'm going to do 4 minus 3 squared plus 6 minus negative 1 squared, which gives you a 4 minus 3 of 1 squared plus a 7 squared, which is 1 plus 49, which is radical 50. So now let's check. Okay, our distance 1 squared plus our distance 2 squared, well, that's our radical 5 squared plus our radical 45 squared, which will be a 5 plus 45, which equals 50, which does equal our last distance, radical 50 squared. So the sum of the squares of the lengths of the shorter side, which is 50, and when we added the 5 and the 45 together, this is equal to the square of the length of the longest side, which is radical 50 squared. So they are vertices of a right triangle. So now we're going to have to try it again, but it's a little more funky setup. But sometimes it's good to kind of graph to see which will be your legs and which will be your hypotenuse. So you're going between 1, 0 and 7, 0. 1, 2, 3, 4, 5, 6, 7. And 7, 5. 1, 2, 3, 4, 5, 7, 5 right here. So now I'm going to give you a hint. Okay, anytime you have something that's a vertical line and a horizontal line, you don't actually need to count the distance. The distance is only difficult when it's a diagonal like this. This is a horizontal and it goes 1, you have 1, 2, 3, 4, 5, 6, 7 between them. Actually, it should be 6. 1, 2, 3, 4, 5, 6. Did I put this on our point? This is 1, 0, and 1, 2, 4, 5, 6, 7. Oh, this should be over here, this way. So there should be, between 1 and 7, there should be 6. And here you're going from 0 up to 5, so this should be a 5. And I only need to really calculate that distance. But just to show you how to do it without doing that, we'll do our distances. So our first distance we'll do between 1, 0 and 7, 0. So I have my radical, subtract my x's, 1 minus 7 squared, plus 0 minus 0 squared, my y squared, which gives me a radical negative 6 squared, plus 0 squared, which is a radical 36. Next I'll do distance 2. I'm going to go between 1, 0 and 7, 5. That's actually going to be my hypotenuse. So I see that I can have 1 my x minus 7 my other x squared plus 0 minus 5 squared. X is subtracted squared, y subtracted squared. So that'll give you a negative 6 squared plus a negative 5 squared, which is a radical of 36 plus 25, which, let's see, that'll be 56, radical 61. And our last length, then we have to go between 7, 0 and 7, 5. So you'll have radical 7 minus 7 squared plus 0 minus 5 squared, which will be a radical 0 squared plus negative 5 squared, which equals a radical 25. So now I have radical 35, radical 61, and radical 25. Well, I can see if I add together radical 36 squared, you want to take your two smaller ones will be your legs. And then this radical 25 will be a leg 25 squared. And I want to see if it'll equal radical 61 squared. And well, it will, because I'll get 36 plus 25 equals 61. That is true. So yes, this is a right triangle. So go ahead and check number 4 on your own. We are on our last page. So now we're on to midpoint formula, which actually is a lot easier than distance formula. Okay, so basically it says the midpoint between 2 points. So we still have two coordinates, x1, y1, and x2, y2. So basically our midpoint is just that it is a point. So your answer is a coordinate with those fun parentheses, and it's still x comma y, but it'll be add the x's together, so x1 plus x2 over 2 and y1 plus y2 over 2. So basically add your x's, divide by 2, add your y's, divide by 2, and you get your new x and your new y, your new point. Okay, so I want to find the midpoint between negative 3, negative 1 and 2, 4. So let's find my x's first. So I'm going to add them together, negative 3 plus 2, divide by 2. So that'll be negative 3 plus 2, negative 1 over 2. And now I just add my y's together, negative 1 plus 4 over 2, which will be a 3 over 2. And you can leave it just like that. So my midpoint is negative 1/2 and 3 over 2. And from the graph, you can see that this would be about the halfway point between here, which is at negative 1/2 and 1 1/2, or negative 3 over 2. So just like that, easy peasy. Let's try a couple down here. So my midpoint is add my x's, 3 plus negative 2, divide by 2, and add my y's, 5 plus negative 3, divide by 2, so it'll be negative 1 over 2, and negative 1 over 2, and positive 2 over 2, which I can reduce, negative 1 over 2, and 2 over 2 is a 1. That is my midpoint. Try number 6. So I have add my x's, negative 7 plus 5, divide by 2, and my y's, add my y's, 4 plus negative 10, divide by 2. So that gives me a negative 2 over 2 and a negative 6 over 2, which reduces to a negative 1 and a negative 3. And that is my midpoint. Easy peasy. Go ahead and try 7 and 8 on your own. Then do another little last video dance because you are done. Congratulations. No more to learn. Just review and then the final and then summer. Happy, happy, happy. Okay, see you tomorrow.